Hello everyone. Today I'm going to talk about dictionary data structures in Python. So dictionary data structure, it is a collection of key value pairs. For example, if you want to store a data like this, where you have a student roll number and along with the roll number, a student is mapped. Like Ram has a roll number 12 and Sham has a roll number 13. So these two values are mapped to each other. So such type of data you can store using dictionary data structure. So for example, you have to just understand the syntax of storing the data. So unlike list where you are storing the heterogeneous values inside an array like data type, this dictionary helps you to store a key and value pair, key and the associated value. So in this case, I'm assuming that my key is unique. All right. So the roll number for all the students can be different, but they can have same values. For example, two students can have same name, but they have different roll numbers. So in that case, I can write another key, and along with this key, the same name can be stored like this. So the key is different, but the value is same for two students. So if you want to store the data like this, such type of data, then you can make use of dictionary data structure. And how we are going to store the data? This data structure is defined by enclosing a comma separated list of key value pairs in curly braces. So you have a curly braces over here and you have key, and in between keys and values you have a colon which separates a key from the value. Then when the next pair comes, you have to give a comma. So in this way you can store the data. So how many key value pairs are stored right now? So three key value pairs are stored for this example. So first key value pair, second key value pair, and third key value pair. If you talk about the syntax of defining a dictionary in Python, then we can define it using three approaches. So if you talk about the first approach, so first of all, dictionary is a class in Python. So in the first syntax, there's a class dictionary, and which is accepting this constructor. This constructor is basically accepting a variable length keyworded argument. So if you do not understand what this means, it means that you can call this dictionary by passing multiple arguments, variable length arguments, and those are keyworded. Keyworded means a key and a value in the form of keys and values. Variable arguments can be passed to this dictionary. So here you can see that you have passed keyworded variable length argument to this dictionary. Keyworded means this is the key and this is a value. So multiple length argument, 1, 2, 3. So in this way you can create a dictionary. That is the first approach. All right. So in the next approaches, you can directly send the mapping also. Okay. So in this case, suppose you have created a dictionary like this, and inside this constructor, you are passing inside the map values, key value mapped as a key value pair, you are passing the values. So in this way, the same dictionary is going to be created. Okay. Only the order is changed. Earlier it was 1, 2, 3. Now the orders are changed, but the same dictionary will be created at the end. Once you compare the values which are existing in all the dictionaries, it comes out to be true. So next is iterable. So you can pass an iterable type item also inside a dictionary. So for example, look at the fourth one where you are passing a list of the items. So a list of items, it is what type? It is iterable type. So you can pass such type of values inside a dictionary to create it. So it's quite simpler to create a dictionary in Python. So there are various approaches and you can pick any of the approaches according to the requirement. So let's take one example. Let's take the IsFirst approach. So in the first approach, I am passing multiple arguments which are of keyworded type. So once I print the value of A, I'll get the dictionary in the form of how dictionary is stored as a key value pair which are separated by colon, and we have a curly braces to define a dictionary. So in this way you have stored it. But here you can see a representation like this. But if you talk about the memory representation, how the values are actually stored in memory, then we have to understand concept in Python dictionary. So first of all, you need to understand Python dictionaries are implemented as hash tables. So what it means? It means when you try to store these values, let me just copy it. All right. So when I'm writing something like this, I am trying to create a dictionary. But in the memory, how the values are stored. So in the memory, we are using the concept of hash tables in computer science. So hash tables are like this. They are like array. Hash tables are like arrays, and where you have index values. For example, this is your array where multiple locations are there. Okay. So in this type of data structure, you are going to now store these key value pairs. So how the values are actually getting stored, that we are going to see one by one. So first thing is, this is what? This is your hash table. Or we can just write it over here. This is your hash table, this data structure. Now next part is, hash table is just a contiguous memory block of memory. Contiguous means one after the other, the memory is allocated. Next, each entry in the table is actually a combination of three values: hash, key, and value. It means every single what entry. So this is your first entry, this is your second entry, third entry, and so on. So it contains three values. First is the hash. I'll tell you what this hash is. Second is the key, and third is the value. Now we'll see how this hash is generated for a particular key value pair. Let's say you want to store such type of data. So in this type of data, first a hash will be generated for these keys. So for all key values, so there are three key value pairs. So for all the keys, hash will be generated first of all. So hash code, how the hash codes are generated in Python? Using a hash function, you can simply pass this key over here. So these keys, let's say they're in form of strings, and you can pass string value 1 to see what is the hash of this value. So the hash of 1, the hash code of 1, which is a key, comes out to be like this. Similarly, you can find out the hash value of 2 as well. So first of all, what happens is, the hash value of all the keys will be generated. So see, the hash values are different for different keys generally. So now what happens after that is, each only that is fine. Now dictionaries work by computing a hash code for each key stored in dictionary using built-in hash function that we have already seen. Now the hash code varies widely depending on the key that we have seen. It varies depending on the key. Generated now are then used to find out the location in this hash table. Suppose the location of the hash table, all these, let's say, values, they occupy the index values like this. Suppose these are the index value inside the hash table, just like your arrays. So now how this hash code is now converted into these locations, that's we have to see. So in that case, one hash function you have to apply on this hash code to generate that index value. For example, for the sake of simplicity, I'm going to take this hash code, and let's say you divide this number by 2 and you take out the remainder. So let's say that is your location for first key, that is 1. And let's say this is your location for second key. Similarly, you can find out the same thing for the third key as well, for the key value pair. So I'm just neglecting this negative index over here to make it simpler. So let's say if you execute these two, instead of 4, let me write 3. If you find out the values, you can see the A value comes up to be 1 and B value comes out to be 0. So in this example, if I use this functionality, what is the function over here? Take the hash code, divide this number by 2 and take out the remainder. So let's say this is a very basic hash function I've used here. So in general, practically, a more complex version of this function is being used. So right now, for sake of simplicity, I'm assuming that my first key value pair is occupying the memory location 1. So how this value will be stored? See, the first value will be stored. First, the hash code will be stored. What is the hash code for the first value? 1. Let's say this number. This entire number will be stored here. Next is the key. What is the key? 1. O-N-E. Next is the value along with associated with this key is stored. That is 1. So in this way, the items will be, the key value pairs will be stored in the hash table inside the memory. And those values can be accessed using these generated hashes. These index values are generated by using hash functions. So this is just for simplicity, I took a very basic function over here. So in this way, the memory is being allocated. Now let's take the same example. So suppose there is 1, and let's say there is 2, let's say there is 3, and assume that we have a value key once again. So let's say I want to store this same value, the different value to the same key. Now what happens in that case is, in this 1, initially this was occupying the memory location 1. Now obviously this value will be replaced by 2. If you check the output, you won't get any error, but instead of that, the new value is now stored. See, now 1 is your key, but instead of value 1, this 2 will be stored over here. So why? Because of hash tables in Python. Hash tables inside the dictionary data structures. Why in what cases these hash tables are useful? They are very useful when you want to search for a particular element in this dictionary. For example, let's assume that if you want to check if this 3 exists in, suppose you want to check if this key exists in this dictionary or not. So if you want to check something like this, so the complexity, what will be the time complexity of this statement? So instead of searching in the entire dictionary, it will only search, it will directly go to the index value and search whether the item is present or not. So the time complexity will be reduced to order of 1 in the best case. So unlike list, which actually does what? Let's take an example where you have a list and the items are stored like this. And I want to check whether 4, this item exists, if 4 exists in A or not. So what will be the complexity in this case? If 4 is your last element, then in that case, in your list, 1 by 1 items are getting checked. So first this 4 is checked with 1. If 4 is equals to 1, no. 4 equals to 3, no. 4 equals to 2, no. 4 equals to 4. Finally, your search is successful, and then you'll say, yes, the item is present. So let's say this is your list, and you check if 4 in list. Sorry, 4 in list is sufficient. So you can directly say this 4 existing in the list, but at the end. So you had to traverse the entire list to check whether a particular item exists in the list or not. So instead of doing that, in dictionary, what happens is when you check if you check what is your dictionary, you can print it. So this is my dictionary. Sorry, now the dictionary is changed. Let's say B is the name of the dictionary, and I want to check whether my key 1 exists in dictionary or not. So value will be true. But why this? How this value is coming as true? How it is going to make the search? You'll have to see. First of all, what happens is it will find out the hash code of 1. So what is the hash code of 1? Which is already stored over here. So let's see, the hash code of 1 is identified as this number. Then a location. Then based on this formula, you'll find out the index of 1. So simply, once you get the index of this key 1, you can directly go to this index value and check whether the item is present or not, this key exists or not. So it is not going to check the entire table. It is just going to check the index which is coming from the hash function. So that is why the search operation becomes very easy, and it is occupying it is using a very less time as compared to list search. So that is why dictionaries are very useful in this case. So next step we are going to see is how we can modify a dictionary, how we can delete the items from dictionary, and so on. So first of all, so these steps one by one we are going to see. So first step is adding values to dictionary. Let's take an example where you have a dictionary with the name faculty and where you are going to map the name of faculty with the subjects. For example, suppose there is a faculty Ram and Ram is teaching you C language. And there is a faculty, how we are going to store the value? There is a faculty Sham and Sham is teaching you Java. And we have a faculty name, let's say Sita. And Sita, let's say, is teaching you Python. So you can write something like this. Now you can see there are 3 keys, Ram, Sham, and Sita, and there are 3 values, subjects associated with them. So if you print out the value, you can simply say the answer is the key value pair is being maintained. A dictionary is now created. Now you have print out the details. Let's say I want to specifically find out which subject is taught by Sham. So I have to give the value of key, make sure. Now in this dictionary only, let's try to access the values. So from Naukri profile, this is my dictionary. Let's say I want to access the recent job, recent occupation of Rama. So if you talk about the recent occupation, I cannot give the index value 0, 1, 2 that we have already understood. So what you have to pass, obviously, the key value, whatever the name of the key is. So past jobs, if you retrieve this value, you will get what? These values in the form of list. So I want to retrieve the last value. Then you can simply write -1. Negative indexing is allowed in case of list. So you will see, you can easily find out this analyst from this entire data structure using this syntax. So if you're unaware of list data structures, the link is provided in the description box. You can go there and understand the topic list. So this comes under slicing operation, which is very much possible in case of list. And this way you can easily retrieve the value from the list of values. Now we'll see some operations which are applicable. So dictionaries have some of the same operators and built-in functions that can be used with strings, lists, and tuples. So we are going to see the same set of operations that we can use in these data structures as well. For example, in and not in operators. Let's see what in and not in operator does in case of dictionary. So if I say, let's take the same example, file. Now this is my dictionary, and if I want to check whether a particular item exists in the dictionary or not, so I can make use of in operator. So you can say Naukri profile, what item you are looking for. Let's say you are saying this last name exists in Naukri profile or not. So it will lead to true. And if you say name, it will lead to false. So these are the operators. They are applicable for dictionary as well. Now let's say if I use items, that is a different function. This is also a very handy function that you can use. So if I use items on this dictionary, you'll get a list of key value pairs. If you check the type, this is a list of key value pairs of these items. If you want to, let's say, retrieve all the values from the dictionary, one by one, if I have to retrieve all the values instead of key. So what you can do is, you can simply make use of, you can iterate over this for I in Naukri profile.items. It means you are trying to iterate over this list and you are trying to print which value. This is my sectex. So if I want to retrieve this full value, I have to give I. I means the first key value pair. And I of 0 means from this 0th index, from this 0th key value pair, the first value I want to refer to. If I give 1, it is going to give me this value from this entire key pair. Since I have used a loop, so it will give me Ram. Second time it gives me Sham. Third time it gives me this entire value. Fourth time 10. So let's check the output. You can see I can easily retrieve all the values from this dictionary using this very handy function called items. Similarly, if you want to just retrieve all the keys, you can write Naukri profile keys. And if you want to just retrieve all the values, so you can write dot values. These functions are very easy to remember because these are also called as key and these are called as values. And if you want to retrieve both key value as item, as a list of items, then you can use items function. So next, okay, so we have covered all these points. And next we'll discuss about a question from dictionary topic. We'll talk about this topic dictionary. The same question which is based on dictionary. Next we'll talk about default dictionary in the next lecture. Thank you so much.